Dear students, welcome to another exciting new session of mobile and pervasive computing. Today we are on to lecture 15th and we were discussing mobile and pervasive platforms. वो platform जिनके लिए हम programs बनाना चाहेंगे. और इसके लिए जो हमने order decide किया, that is based upon the popularity of the platform itself. We looked into what are the worldwide sales of smartphones और उसमें what are the dominant operating systems that goes inside them. And then we started dissecting them. इस सिलसिले में हमने सबसे पहले Symbian को देखा because Symbian was the most widely sold operating system. उसको हमने देखा कि what are the things it is composed of. उसके OS का structure क्या है, what are the entities that goes inside that operating system, what are the design decisions that we took when we designed the Symbian operating system, and then what are the devices it works on. उसके बाद we moved our discussion to Android platform because Android is the next upcoming platform, and we said that it is, in some research studies, it has already surpassed Symbian, but some says that it is still little bit behind. लेकिन एक बात हम वाज़े तौर पे कह सकते हैं कि this is an upcoming platform and it will soon surpass Symbian, given that Symbian has also announced कि वो बहुत जल्द Symbian की support को ख़त्म कर देगा. So let's start with where we left last time. और हमने last time जो है वो एंड्रॉयड के ऑपरेटिंग सिस्टम के आर्किटेक्चर को डिस्कस करना शुरू किया था. अब स्क्रीन पे मैं आपको वो आर्किटेक्चरल डायग्राम दिखा रहा हूं विच डिफाइंस द डिफरेंट लेयर्स ऑफ एंड्रॉयड ऑपरेटिंग सिस्टम. हमने नीचे से अगर शुरू करें तो हमने वी स्टार्टेड विद लिनक्स कर्नल. द कर्नल एज वी सेड इज द कोर ऑफ एनी ऑपरेटिंग सिस्टम. इसमें हम डिसाइड करते हैं द कोर फंक्शनैलिटीज. What would be the core functionality that the operating system will have and where it will go. So kernel is the very heart of any operating system. Embedded operating system, जिसका एक member जो है वो Symbian OS था and second member is Android. We have some constraints that we have to work within. एक constraint उसमें ये भी होती है कि we don't have much space left for us. क्योंकि device छोटी होती है, we have limited storage space, और उसी storage space में we have to let user work, we have to let programs work, and operating system has to reside in the same space. इसलिए operating system को भी हमें shrink करना पड़ता है. जब हम operating system को shrink करने की बात करते हैं तो हम kernel को भी shrink करते हैं, and then it is a tough choice. We make trade-offs that which things or which functionalities goes inside the kernel and which are the functionalities that will be outside the kernel. So then in this diagram, what we start with is Linux kernel. जैसे कि हमने discuss किया that Android is based on Linux kernel. Though it's not Linux, but it is based on Linux kernel. It started with 2.6.24, जो कि इसका बिल्कुल पहला version था. It was based on this Linux kernel. और उसके बाद it has come a long way. Nowadays I think it is about 2.6.34 or 38. So they start adopting the Linux kernel. उसके बाद Linux kernel के बाद the next layer that comes is the native libraries. The native libraries are the ones that are written in C++, and they provide core system functionalities. Along with native libraries, there is an Android runtime. A runtime is an environment which provides the Android with the platform जहाँ पर उसके सारे programs run करते हैं. On the top of libraries and Android runtime is application core framework, या वो core libraries जो कि Android के framework में built in है. And on the top of this all is the applications themselves. Your messaging application, your dialer application, your browser, all this comes on the top of it. इस डायग्राम को दिखाने का एक मकसद ये भी है to see how things are differently color coded. अगर आप नोट करें तो Linux kernel is a totally different color. Then on the top of it, the things written in C++, that is your native libraries, that has a different color. लेकिन ऊपर की जो दोनों layers हैं, they are in bluish color. Why is that? We are using bluish color here to represent Java. That all these things that are bluish in color are the Java libraries either, or the things written in Java. So the top two layers, that is your application framework or core libraries, and the applications themselves are written in Java programming language. और उसके नीचे हमारे पास C++ का environment है. Linux kernel को तो हमने adopt किया, लेकिन we have modified Linux kernel a lot. उसमें जो बिल्कुल obvious differences थे जो कि हमने discuss किए last time, one was that we don't have glibc support in Linux kernel that comes inside Android. ये किस लिए हुआ? ये इसलिए किया गया because Android is an open source. जब आप open source की बात करते हैं तो open source are normally distributed under the GPL license. GPL license के लिए हम एक term use करते हैं copy left. Copy left means कि वो कोई भी सॉफ्टवेयर जो GPL के कंपोनेंट्स को यूज करते हुए बनाया जाए उसको आपको पब्लिकली अवेलेबल करना पड़ेगा. तो अगर कर्नल में, और glibc एक ऐसी लाइब्रेरी है जो कि if you write any C++ program it will be used inside it. So if you are writing anything using glibc, you have to make your program available under GPL or general public license. Some vendors might not like this idea, और हम अभी थोड़ी देर तक उसको डिस्कस करते हैं again कि what are the constraints there. लेकिन the point here is कि Linux kernel was modified from its original to a great extent. उसमें बहुत सारी चीज़ें ऐड की गई, बहुत सारी चीज़ें रिमूव की गई. glibc is a very prime example of a very crucial component of a library that was removed from there. In addition, we added shared memory support inside it. We added our own power management support inside it. We added the kernel debugging support. We added alarms in there. We added logging in there. So क्वेश्चन यहाँ पर यह आ जाता है कि अगर हमने एक तो सबसे पहले हमने बहुत वाइटल कंपोनेंट निकाला और उसको हमने परे रख दिया, उसके अलावा फिर हमने वी एडेड टू मच ऑफ आवर ओन स्टफ. ये इसी तरीके से अगर आप सॉफ्टवेयर इंजीनियरिंग से थोड़ा सा इफ यू हैव गॉन थ्रू मॉडिफाइंग समबडीज एल्स कोड, तो एट सम पॉइंट यू फील लाइक कि जब आप मॉडिफाई कर रहे होते हैं, बिकॉज मॉडिफाइंग इज़ अ वेरी कम्बरसम टास्क. पहले आपको उस प्रोग्राम की पूरी लॉजिक अंडरस्टैंड करनी पड़ती है. देन यू हैव टू अंडरस्टैंड कि जिस बंदे ने लिखा है उस व्हाट डिज़ाइन ही फॉलोड, किस तरीके से उसको लेके चला. एंड देन फाइनली यू हैव टू एम्बेड योर ओन लॉजिक. सो इट बिकम्स ट्वाइस द टास्क एज नॉर्मली राइटिंग योर ओन कोड. तो सम पीपल नॉर्मली फील कि अगर आप उन्हें कोई मॉडिफाई करने के लिए कोड दे दें तो दे नॉर्मली फील कि इट्स बेटर दैट इफ आई राइट माई ओन बिकॉज दैट विल टेक लेस टाइम एंड इट वुड बी अ बेटर पीस ऑफ कोड. क्योंकि फेस इट नॉर्मली अ सॉफ्टवेयर इज बगी, लेकिन जब आप उसको दो डिफरेंट लोग उसको मॉडिफाई करें तो देर आर मोर चांसेस दैट इट हैज़ मोर नंबर ऑफ बग्स. तो यहाँ पे भी यही क्वेश्चन आएगा कि वाई आपने जब इतनी सारी मॉडिफिकेशंस कर दी, यू टेक आउट सम मेजर कंपोनेंट्स, देन वाई डू डिडंट जस्ट राइट योर ओन, जिस तरह सिमियन वालों ने किया कि आप अपना ऑपरेटिंग सिस्टम का कर्नल लिख लें. द आंसर इज द फंडामेंटल्स दैट कम्स विद द लिनक्स कर्नल, एंड द फंडामेंटल्स दैट कम्स विद द लिनक्स कर्नल आर द मेमोरी एंड प्रोसेस मैनेजमेंट. That is a very vital component that Android inherited. Then we have the security model, and the Linux works on permissions-based security model as opposed to the role-based security model. And the permission-based security model is what Android inherited. Then the driver model of Linux is very much different from that of Windows. Windows में क्या होता है, because Windows is a closed source environment. So what it guarantees is that it will give you sufficient APIs that anyone wanting to write a driver on the top of it can do so. इसके लिए it will provide you some APIs, some access drivers कि जी आप ये API use कर लें for if you want to write an audio driver, if you want to write this, you can do this, and it will define a very broader range of APIs so that vendors can write APIs on the top of it. Linux, on the other hand, because it's an open source environment, opted for a different driver model. Its driver model is that the drivers are also committed to the kernel as the source code, और उसके बाद they go through a very regressive cycle of community parsing them. So these drivers go through various cycle of people looking at it, people trying it, people modifying it, and then at some point they get robust. And after that, these drivers are then released alongside the kernel. So this is the kernel in Linux. This is how the drivers are embedded. And this is somewhat Android's model R2. We will look at shortly कि Android जो है वो driver model किस तरीके से उसको लेके चलता है. But this is Android's driver model is along the same lines. Because again, Android is an open source. And the final break of this adoption is this very sentence, open source. Linux kernel is open source. So that changes the whole thing that, okay, because Android is open source, it makes a lot of sense to adopt for a software or a kernel that is also open source. Kernel के ऊपर जब हम जाते हैं तो we start talking about native libraries. अब native libraries को हमने just for the sake of understanding, and it is important that I stress this point here, कि we are talking just for the sake of understanding. This is not an official classification. For the sake of our understanding, हमने इसको 4 हिस्सों में divide किया. We started with that bionic libc. Then the second component for our distinction or our classification was the function libraries. Third component was native servers, and then fourth component of this native libraries is hardware abstraction layer. So these are the 4 components that we classified the core libraries into, core C++ libraries into, and these are the libraries that do most of the heavyweight work for us. इसको थोड़ा सा डिटेल में देख लें अगर तो bionic libc, the first and the most important component, यहाँ पर आपकी वो GPL clause apply होती है. And why is that? Think Android. अब Android ले लें या आप Symbian ले लें या कोई भी embedded operating system ले लें, you are targeting a wide number of devices. अब you would want कि ये हर device में it would run perfectly okay. थोड़ी सी इसमें जो आपके पास रिस्ट्रिक्शन आती हैं, यहाँ तक मॉडल हमारा सेम है. हम डेस्कटॉप में भी जब भी हम कोई ऑपरेटिंग सिस्टम बनाते हैं तो वी वुड लाइक एवरीथिंग टू रन एज गुड एज पॉसिबल. लेकिन यहाँ पे फ़र्क ये आ जाता है कि डेस्कटॉप में वी हैव अ लॉट ऑफ स्पेस फॉर ऑपरेटिंग सिस्टम. आवर ऑपरेटिंग सिस्टम कैन इवन ऑक्यूपाई GBs ऑफ स्पेस एंड वी स्टिल वुडंट वरी. और हमारे पास अगर ड्राइवर नहीं है कोई तो वी कैन ऐड एडिशनल ड्राइवर ऑन द टॉप ऑफ इट टू मेक आवर न्यू डिवाइस वर्क, एंड द एडिशनल स्पेस इट वुड टेक probably wouldn't hurt us. In mobile environment, this is not the case. We are talking about embedded operating system. So our devices, first of all, they are limited, but then vendors has to be very careful on how to implement the drivers of it. क्योंकि we don't want the size of it to increase. The idea of Android is, और जिसकी वजह से Android ने इतनी मार्केट भी गेन की, इतनी पॉपुलैरिटी भी गेन की, the idea is the Android or the Google people say, or the Open Handset Alliance जो कि उन्होंने फॉर्म किया, they say, okay, leave the hard work to us, we will make the operating system for you. हम आपको ऑपरेटिंग सिस्टम बना देंगे, और वेंडर्स का काम क्या होगा, या जो आपका हार्डवेयर बनाते हैं उनका काम क्या होगा कि दे विल आइदर पोर्ट this operating system onto their own device, और अगर वो एक हार्डवेयर वेंडर है तो इफ वट एवर हार्डवेयर इट इज मेकिंग वो उसके लिए ड्राइवर्स बना के हमें दे देगा. So we will do all the hard work and you are the people who will port it for yourself, who will write drivers for it and then embed, ship it on your devices. And because it's open source, we wouldn't cost you anything. All the cost involved would be the money you will spend on porting it or writing the new drivers of your devices. अब अगर आप कर्नल में glibc डाल देते हैं और glibc is something that is very crucial for any system because इसमें आपकी system libraries हैं, इसमें आपकी math libraries हैं. The core functionality of any C++ या core functionality of any Linux or Unix type system is captured inside this library. अब अगर आप कोई भी ड्राइवर इस लाइब्रेरी को यूज करते हुए लिखते हैं तो because this library is provided under the open source license or GPL, आपको अपना ड्राइवर भी ओपन सोर्स के अंडर या GPL के अंडर अवेलेबल करना पड़ेगा. Now some vendors might not want to do that. Some vendors might have some algorithms, some very fantastic algorithms that they have spent millions of dollars over it and spent number of years coming up with, and they wouldn't be willing to put that algorithm or put that piece of software under the GPL because that will take away their market advantage. Think about it that there is a program that does audio very efficiently. Yeah, there is a program that works with multimedia very efficiently. And you are, because अब आपने जो उसको C++ में लिखा है and you use glibc, you would be required to make it available to general public under GPL. Then all the other market players would definitely jump into the bandwagon and copy that software for you. So your market advantage will go up. So इस चीज को टैकल करने के लिए what Android did was that they write their own libc, own custom library and put it inside the native C++ space. जहां पर आपकी native C++ libraries हैं वहां पर libc को भी डाल दिया. Now it has come out of the kernel space, GPL की space से निकल गया. Still it is open source, लेकिन Android ने इसको under less stringent term दिया. So anybody, and the terms of the license are such that anybody who will use this library for writing their programs doesn't necessarily have to make it open source too. So now you are safe from that perspective that if you write something using libc, then you will be able to keep your copyrighted material. इसमें libc को अब, now we are talking about embedded environment, we are talking about number of constraints. तो जब हम इस constraints की बात करते हैं तो libc चूंकि एक ऐसा process है जिसने तमाम process के साथ coordinate करना है. Because think about the number of programs you have written in C++ today. और उसके सोचें कि उनमें से कितने प्रोग्राम्स के शुरू में आपने include stdio.h लिखा है या include iostream.h लिखा है. Probably all of them, because all of them has input and output component and all of them has this, and this library eventually goes to the glibc. So this library is shared among number of processes. So you have to keep it very small. उसका footprint आपको बहुत small रखना पड़ेगा, because if you keep on replicating this library among different processes, then it will take up lot of space. यहाँ पर एक और चीज जो कि Linux kernel आपको provide करता है, that is the sharing of libraries. Such libraries like libc and glibc, Unix or Linux has a very robust model to share such libraries. That is, if number of processes are using the same library, only one instance of such library will be loaded into the memory और उसके बाद तमाम उसको यूज कर सकेंगे. So this is part why libc and why not glibc. फिर libc को एफिशिएंट बनाने के लिए उसका साइज भी रिड्यूस किया गया. बहुत सारी ऐसी चीजें जो कि glibc में सपोर्टेड and they are not any longer supported in libc. All this effort to make it more fast, more efficient, less memory footprint, लेकिन इसके लिए जो आपको कॉस्ट देनी पड़ी वो ये थी कि अब you can't simply take any program from a Linux space and think that okay, this is something from Linux, it has works on Linux, it should work, and it use very primitive constructs, so it should work on the Android environment too. No, this wouldn't be the case. Why not? Because in Linux you are using glibc to compile your programs. In Android environment we are talking about libc, and libc doesn't contain all the functionality that is in glibc. It has some additional functionality, yes, to make it fast, to make it optimal, to optimize things, lekin it doesn't contains all the glibc functionality. For example, एक छोटी सी example आपको देता हूँ यहाँ पर कि the C++ exceptions that are part of glibc are not inherited in libc. तो अगर आपने कहीं पे exceptions use की हुई हैं, you wouldn't find that support in your libc. नेक्स्ट कंपोनेंट जो कि एंड्रॉयड की कोर लाइब्रेरीज में था इज द फंक्शन लाइब्रेरीज. अब फंक्शन लाइब्रेरीज वो लाइब्रेरीज हैं डज सम वर्क फॉर यू. दीज आर द लाइब्रेरीज दैट यू कैन यूज फॉर गेटिंग वर्क डन. व्हाट आर द एग्जांपल्स ऑफ इट? वन ऑफ द प्राइम एग्जांपल ऑफ सच लाइब्रेरी इज SQLite. SQLite is an open source relational database. You are probably familiar with other types of it that we use in desktop or server environment like Oracle, MySQL. This is the trimmed down version of such a family, and it is modified to fit the needs of embedded devices. These core libraries, they are providing the basic functionalities that are on the core of Linux operating system. अब ऊपर वाली लेयर से नीचे आते जाएंगे तो you would eventually find that these are the libraries that end up getting used. SQLite की एग्जांपल को ही अगर लेके चलें तो on the top और या on the application layer you have MMS और you have SMS और या आपके पास contacts हैं. All these functionalities goes through the various layers of abstraction and end up in SQLite. SQLite would have a database maintained for your SMS, for your MMS, and for your contacts, and a number of other things. So these are the libraries that do the actual work in the Android operating system. SQLite के अलावा we have the media framework that is responsible for handling all the audio, video, codecs, showing pictures, showing movies, rendering the image on the screen. All this is done through the media framework. Then another example of such a library is WebKit. WebKit is a heavyweight browser engine that is again open source and is able to render rich web for you. तो इसमें आपका CSS आ गया, इसमें आपका DOM आ गया, इसमें आपका HTML आ गया. So all these exotic functionalities that you get in the desktop environment even is inherited by WebKit, और वही WebKit जो है वो आपके पास Android environment में भी available है. The similarity of all the three ये जो हमने अभी डिस्कस की libraries, WebKit, SQLite and media framework, they are all open source. So this remains the core, or this remains the prime of Android operating system, that anything that will be used inside it will be open source, because eventually the whole system has to go open source. Media framework in turns जो उसके लिए open source library use की गई है, that is called open core. So the open core library is used for a media framework, and this is again an open source library. Functional libraries के बाद we have native servers. Native servers, again ये हमने नाम अपनी आसानी के लिए दिया है. Native functions are those libraries or those functions or those methods that handle input and output for us. इसमें जो दो examples मैं आपको यहाँ पर दूंगा, one is called Surface Manager or Surface Flinger, and the second is Audio Manager or Audio Flinger. Surface Manager क्या करता है? Surface Manager तमाम एप्लीकेशन से उनकी स्क्रीन्स या उन्होंने जो डिस्प्ले करवानी होती है एलिमेंट्स वो इकट्ठे करता है एंड देन इट डिस्प्लेज ऑन इट स्क्रीन. पास किस तरीके से होते हैं? व्हेन एन एप्लीकेशन डज or have some elements that it wants to put it on the screen, it passes through a buffer and through IPC calls. And if you remember, in Android, the IPC calls are done through the binder. And we discussed binder in detail in last few lectures. So, binder या IPC के through ये buffers जो हैं ये surface manager को pass होते हैं, ये surface flinger को pass होते हैं, जो कि एक frame buffer में उनको draw कर देता है. So in screen, if you see, we have the example. I have one example there of how the surface manager works. I have an application A जो आपका background draw कर रही है, and it also has certain elements जैसे कि आपकी network connectivity किस तरह की है, आपके पास battery power कितनी है, and all those things. So these are the two elements that has come from application A. The second element is being passed, or second surface is being passed from application B. We have drawn some random thing in application B and now we want to put it on screen. ये तमाम screens जो हैं they are passed to surface flinger और surface manager, और surface manager ने उसको combine करके आपकी screen पे show कर दिया. Surface manager is capable of handling 2D or 3D graphics, and then it is also capable of handling input from multiple applications. तो आप बहुत सारी applications से input gather करके, screens gather करके, then it will be able to draw it on one screen. Because in Android or in any cell phone for that matter, we have only one screen where we will show you the output. It will decide what goes up, what goes down, कौन सी एप्लीकेशन है जिसका आउटपुट जो है वो ऊपर आएगा, कौन सी एप्लीकेशन है जिसका आउटपुट नीचे आएगा, एंड सो ऑन. Just like surface manager or surface flinger combine the surfaces from different applications and show it to on screen, for audio we have a similar manager that is called audio flinger or audio manager. Audio flinger or audio manager क्या काम करता है? It collects voice from different channels. आपकी गेमिंग वॉइस हो गई, आपकी माइक की वॉइस हो गई, आपकी किसी एप्लीकेशन से जनरेटेड वॉइस हो गई. इट कलेक्ट्स ऑल द वॉइसेस एंड देन इट राउट्स इट टू अप्रोप्रिएट चैनल और इट राउट्स इट टू अप्रोप्रिएट आउटपुट. आपने हेडफोन पे सुनना है, आपने फ़ोन के स्पीकर पे सुनना है, वेयर एवर यू डायरेक्ट द एप्लीकेशन टू प्ले दिस साउंड फॉर यू, दिस इज व्हाट द ऑडियो फ्लिंगर वुड डू. सो इट विल कलेक्ट ऑल द वॉइसेस that are part of the applications and then it will route it to appropriate output channel. So this is what the job of audio flinger is. So these are the two example of native servers that are used in Android. Now the last and perhaps a very crucial component of the native libraries is hardware abstraction layer. हार्डवेयर एब्स्ट्रैक्शन लेयर, चूंकि हम नेटिव लाइब्रेरीज की बात कर रहे हैं और नेटिव लाइब्रेरीज को जब मैंने स्टार्ट किया था तो मैंने यही कहा था कि दीज आर द लाइब्रेरीज दैट आर रिटन इन C++. तो हार्डवेयर एब्स्ट्रैक्शन लेयर्स आर अगेन द ड्राइवर्स दैट आर रिटन इन C++. दीज आर नॉट इन कर्नल स्पेस, वी आर ऑलरेडी आउट ऑफ कर्नल स्पेस. हमने कर्नल की जो लेयर थी उसको हमने छोड़ दिया पीछे एंड नाउ वी आर इनटू द नेटिव C++ लेयर व्हिच इज इन यूजर स्पेस. सो दीज आर द native hardware drivers written in C++ residing in user space, and this defines the interface of Android operating system to the hardware layer. तो hardware और उसके दरमियान आपने एक additional layer introduce करवा दी that we call hardware abstraction layer. अब यहाँ पर question ये आता है कि why another layer of hardware abstraction या why another layer of hardware drivers? क्योंकि आपके पास कर्नल के अंदर भी तो ड्राइवर्स हैं. You have number of drivers that are in kernel. So why we are writing our own another set of hardware drivers? The reasons are many, और हम उस reason से start करते हैं जो कि we have probably understand a bit, and that is GPL. अगर आप कर्नल में कोई चीज़ भी इम्प्लीमेंट करते हैं, लाइक अगर आप ड्राइवर्स भी इम्प्लीमेंट करेंगे अपने So it will become again a GPL. GPL would mean that you will have to distribute it freely. So GPL might not be the license of choice for those vendors who have intellectual property right associated with their drivers. ये तो हो गया एक रीज़न. दूसरा रीज़न ये है कि एंड्रॉयड और या लिनक्स कर्नल स्पेस में drivers are not that well defined. There are still some devices that doesn't have appropriate drivers in Linux space. ये क्यों है? ये इस रीज़न की वजह से भी हो सकता है कि we have newer devices coming out every day. And second is that the mobile devices use some resources that are not present in mobile environment or desktop environment, sorry. वो कौन सी devices है? For example, GPS हो गया आपका. Now GPS is something that is mostly used in mobile environment. आप desktop environment में या laptop environment में you wouldn't hear about it. Vibrator is another example. When you have put your phone on silent, you have the vibrator on so that you would know that there is a call coming in. अब ये vibrator model भी there is only in mobile devices. आपको desktop में या laptops में ये नहीं मिलेगा. So these are the devices that don't have a very well defined drivers associated with them. इसलिए और third reason is that Android wants very specific set of functionalities out of the devices or out of the drivers. It has a very defined set of functionalities or methods it would expect from a driver. So, for example, for audio device, it would say functionality A, B, C, D, and E. And everybody would have to implement that for consistency purposes. You can't allow every vendor to start writing their own functionalities. So there are minimum set of functionalities that every vendor should be able to provide. Android has a very strict check on it that for every vendor that is providing a driver, there is number of functionalities that it should provide. So providing hardware abstraction layer ensures all these three things. First of all, you are into user space, so you can keep your intellectual property right. Second, now you have a standardized driver model. And third, that you are whatever functionality that Android requires out of your driver is there. So these are the three reasons because of which there is an additional layer of hardware abstraction inserted inside the Android. और एक और रीज़न जो थीम के साथ चलती है, जो डिज़ाइन डिसीजंस के साथ चलती है, वो ये है कि Android in most of the cases stayed with whatever is implemented in the Linux kernel. तो अगर आपने ये डिसाइड किया है कि there is a functionality, let's say X, and Android wants to keep it, so it will keep that functionality and build on the top of it. Power management इसकी एक example है that you have power management already implemented at the kernel level and Android decided to keep it. लेकिन because Android has an aggressive power management, it has built on the top of it the additional model to leverage for embedded devices, to leverage for smaller battery life and all those things. लेकिन जो उसका original model था, that जो कि Linux के साथ आया था, that was kept intact, and then on the top of it you build additional layers. और इसके साथ आप ये भी कह सकते हैं कि जहाँ पर they decided to forego everything, then they write everything from scratch too. And that brings us to very important and probably the heart of the Android runtime. On the top of kernel, on the top of libraries, this is the component that ensures portability of your applications. Android runtime what are the components of it? Android runtime composes of a JVM, except that JVM or Java Virtual Machine in Android is called Dalvik VM, and it has some core libraries. अब वही वाला dilemma कि JVM exist करती है. Android decided that no, it's not good enough for us. it discarded the whole thing and wrote the whole JVM from scratch and called it Dalvik VM or Dalvik Virtual Machine. Dalvik नाम कहाँ से आया है? Dalvik is a place in Iceland and the key architect of it, उसके ancestors were from that place, so he chose Dalvik for this new virtual machine that he was going to build. Dalvik virtual machine run optimized DEX code as opposed to the class files that were run in Java virtual machine. We are not talking about the DEX machine code, which will be run on the Dalvik VM. And the way it works is that your Java classes or jar files are converted into DEX files and that they are run on the virtual machine. Dalvik virtual machine बनाने में जो considerations थी, they are again your battery power, your slow CPU, lesser amount of RAM, and then the most important one is OS without swap space. Android doesn't support swap space. Swap space क्या होती है? Swap space ये होती है कि आपके पास मेन मेमोरी में जब जगह कम पड़ जाती है and you have number of processes running there, but what you do is you pick up some processes and swap them out of memory and allocate that memory to some other process. और जब उस process की दोबारा ज़रूरत पड़ती है, you bring them back into the memory और आप उसको दोबारा यूज़ करें. So there is a space reserved for such processes जो कि memory से swap out होंगे और swap in होंगे. Android doesn't support this concept anymore. You don't have a swap space. So now your virtual machine has to be very, very efficient in terms of space, in terms of running, in terms of time. It has to be very efficient. अब ये efficiency हम किस तरीके से achieve करते हैं? Dalvik को समझने से पहले let's first understand the environment in which Dalvik is going to run. और जब हम थोड़ा सा backtrack करेंगे और we will start from the beginning of the Android और हम देखेंगे कि एक typical device जो कि आज से तकरीबन साल पहले which was marketed, what was the specifications of it? And we will also break down the different access of it. We will talk about memory access and then we will talk about CPU access. तो पहले memory efficiency या memory access की बात करते हैं. तो a typical device, a typical Android device has or used to have only 64 MB of main memory available. 64 MB of main memory available when it's off. जब आप उसको boot up करते हैं तो जो low level processes उसको fill up करना शुरू करते हैं, they take about 14 MB of memory right there and then. So when the low level of booting process completes, you have about 40 MB left for. उसके बाद the high level of processes starts populating the memory, or when they are done, you are again a loss of 20 MB of memory. So 20 MB आपकी वहाँ पर चली जाती. So at the end, when all this completes and all the processes has completed loading themselves into the main memory, you are left with 20 MB of memory. Now in this 20 MB, the user has to operate. In this 20 MB, you have your program, custom-made program has to run. And all these things have only 20 MB or applications that comes with Android. All these have this 20 MB of memory available for them to execute. अब सबसे बड़ा dilemma, you don't have swap space. नहीं तो आप ये कहेंगे कि ठीक है 20 MB है तो कोई बात नहीं है. We will go from एक process से जब हम दूसरे process पे shift करेंगे तो we will probably swap out some memory. लेकिन you can't do it here. Or secondly, Android security model says that every process has its own space for running. हर process के पास अपनी space होती है running के लिए. It is independent of each other. And it is the second process is suspicious. Let's put it this way. हर process को आपने उसकी अपनी space allocate कर दी, and for you, for process A, process B is suspicious. So whenever it tries to invade your space, there is something wrong going on. And this is, in very simple words, OS security model in Android. Every process has its own separate address space, has its own memory, and it is running independent of each other. No swap space, and now everybody has to get its own memory space to run, because every process is, this is what the security model dictates, every process will have its own space. Two dilemmas. And third one is that normally the system library of Android ranges from anywhere from 10 to 20 MB. कोई भी जो system libraries हैं that comes with Android takes up about 10 to 20 MB of space. Now think about fitting all those things. ये जो चार constraints हमने discuss किए हैं, इन चारों को together करें, और उसके बाद think about that we have only 20 MB of space available in Android. हमारे पास अभी सिर्फ 20 MB space available है in Android system. How would we manage that? This is one of the biggest dilemma when it comes to the designing the Dalvik VM. और अभी हम सिर्फ memory efficiency की बात करें, we haven't even moved towards the CPU efficiency. That how would the CPU, how would be the running would be optimized, that is a separate debate. Let's first talk about the main memory itself. To understand this कि हमने memory efficiency किस तरीके से gain की, let's first see into the disk file system और disk architecture के DEX जो था, जो नया file format आया jar की जगह पर या class files की जगह पर, how does that look? और उसके बाद हम देखेंगे कि how does it further optimizes, how this DEX और या उसकी processing को हमने further optimize किस तरीके से किया. As it turns out, जो आपके पास class file generate होती है as a result of any Java process और या jar file generate होती है, it contains lot of redundant information. The idea was to just put labels, just put tags wherever they are required without making any reference. तो अगर आपको किसी इंफॉर्मेशन की जगह किसी जगह पर ज़रूरत है तो इट विल बी पुट इट देयर रिगार्डलेस ऑफ कि कहीं पे वो किसी और जगह पर भी रिपीट हो रही है. तो ये दिस वाज द आर्किटेक्चर ऑफ क्लास फाइल. इट हैज़ लॉट ऑफ रिडंडेंसी इन इट. तो पहली चीज़ जो डेक्स फाइल फॉर्मेट ने एड्रेस की वो ये थी कि इस रिडंडेंसी को एड्रेस किया. नाउ वी शुडंट हैव रिपीटिशंस इनसाइड. हमारे पास रिपीटिशंस नहीं होनी चाहिए. तो द नॉर्मल फ्लो जो कि पहले था दैट वाज कि हमारे पास एक प्रोग्राम लिखा हुआ था, सोर्स कोड लिखा हुआ था, उसको हम कंपाइलर के थ्रू गुजारते थे, हमारे पास क्लासेस जनरेट होती थी, हमारे पास जार फाइल जनरेट होती थी और हम उनको JVM कंपैटिबल वर्चुअल मशीन पर रन कर देते. नाउ द फ्लो इज लिटिल बिट मॉडिफाइड एंड नाउ द फ्लो इज लाइक दिस कि वी हैव फर्स्ट द सोर्स कोड, द प्रोग्राम इटसेल्फ. It again goes through the same process. Compiler जो है उसको classes में convert करता है, compiler उसको jar file में convert करता है. But now we have after that an additional step where we do the DEX compiling. या हम उस class file को या jar file को DEX में convert करते हैं. And then that DEX file we are able to run into the DEX compatible virtual machine, that is the Dalvik VM. So this is an additional step inside. अब ये एडिशनल स्टेप क्या करता है? दिस एडिशनल स्टेप टेक्स आउट एनी रिपीटिशंस दैट आर इनसाइड द क्लास फाइल. अब अगर आप देखें इफ यू कंपेयर द क्लास फाइल विद द डेक्स फाइल, यू विल सी लॉट ऑफ पॉइंटिंग्स अराउंड, लॉट ऑफ एरोज. अगर आप उसको सिंबॉलिकली ड्रा करें तो आपको बहुत सारे एरोज मिलेंगे. इट हैज़ टेक्स आउट द रेफरेंसेज, इट हैज़ टेक्स आउट द टैग्स, इट हैज़ टेक्स आउट द स्ट्रिंग्स, और उसकी जगह इट हैज़ पुट एन एरोज और रेफरेंसेज. Now we have arrows to point towards different structures of or different elements of the DEX file. इस तरीके से we tried to reduce the size of the DEX file itself. ये कितना successful हुआ? The success is that a DEX file is usually half of the size of a jar file. So this is where we gained our memory efficiency, and this is just one dimension that we modified the class file architecture or jar file architecture and we convert it into DEX. We put lots of references inside it, and now we have get efficiency. The storage efficiency मैं इसको कहूँगा क्योंकि this is the file that gets stored in your system, and we get an efficiency of about 0.5, that is half the size of that a typical jar file. So this is one thing. हमने storage में यहाँ पर efficiency gain की. Second, the efficiency that we have gained in the main memory. अब main memory में हमने efficiency किस तरीके से gain की. Main memory की efficiency को explain करने से पहले let's take a little trip down the memory lane to understand what memory management looks like. या कितनी types of memories are there when your program is run inside main memory. Main memory को हम 4 different categories में तकसीम करते हैं. We have private and shared memory, and we have clean and dirty memory. So these are the 4 types of memories or allocated memories, I would say, that are present in the main memory. आप इसको इस तरीके से सोच लें कि we have 2 axes, x and y, and on x axis we have clean and dirty memory, and on y axis we have private and shared memory. So we have 4 quadrants that describe the allocation of the memory. We can have combination of these memories. अब जब आप कोई भी प्रोग्राम लिखते हैं तो when it is run inside the main memory, तो variables gets assigned some memory space. Automatically आपने अपने प्रोग्राम में अगर लिखा int a is equal to 0, तो when this program will run, memory में एक space assign होगी which would be named a, और उसमें एक value रख दी जाएगी, that is 0 in your program. This is one way of assigning memory to variable that is implicit, that you do not do any memory function explicitly. आपने सिर्फ एक variable declare किया, आपने एक object declare किया और उसको memory में space allocate. The second way of doing memory allocation is more explicit, in where you tell the compiler explicitly that okay, this is the variable, this is the object that needs to be stored in the memory, and I need a guaranteed memory allocation for that. इस काम के लिए हम C या C++ में malloc use करते हैं, memory allocation. So we call malloc and we pass it appropriate parameters and it reserves memory for us in the space. क्योंकि हम मेमोरी को हमने एक्सप्लिसिटली डिक्लेयर किया है, एक्सप्लिसिटली गेन किया है, हमें इसे एक्सप्लिसिटली फ्री भी करना होगा, और फ्री करने के लिए हमारे पास जो कंस्ट्रक्ट है दैट इज फ्री. सो एनी मेमोरी दैट इज असाइंड और दैट इज गेन्ड थ्रू malloc इज डर्टी मेमोरी. डर्टी मेमोरी किस लिए? बिकॉज दिस मेमोरी इज अंडर द ज्यूरिसडिक्शन ऑफ द प्रोसेस इटसेल्फ. अब प्रोसेस ने चूंकि उसको एक्सप्लिसिटली गेन किया है, it is the one who will manipulate it and it is the one who will explicitly free it. Kernel can't do anything for that memory, for that particular set of memory. दूसरी साइड पे we have clean memory. अब clean memory वो memory है जिस पे kernel can operate. Kernel can decide whether this is necessary, we can live without it and do multiple operations. इसकी एक example ये है कि you have a page, memory page full of zeros. So kernel knows that okay, I can anytime create a memory page full of zeros whenever required, so I can discard it. Remember, I use the word discard, not swap, because we don't have swap space in Android. Android operating system doesn't provide you swap space. So you can only discard things. And clean memory is the one where kernel has such jurisdiction or such liberty where it can decide which memory is necessary and which memory can be decided on, can be allocated on the run. Page full of zeros, page full of ones, kernel can discard easily because it knows that whenever the requirement comes, it can easily create a page full of 0 and 1 on the runtime. So this is one thing. Such clean memory is usually backed by files. और अगर आप इसको यूनिक्स या लिनक्स की टर्म में देखें तो द टर्म वी यूज देयर इज मेमोरी मैप्ड फाइल्स दैट आर दोज मेमोरी एलिमेंट्स दैट कैन बी ट्रैक्ड बैक टू फाइल. तो जब भी आप उस मेमोरी लोकेशन को पढ़ने की कोशिश करते हैं तो द कंटेंट इज एक्चुअली कमिंग फ्रॉम द फाइल एंड दैट मेक्स कर्नल लाइफ ईजियर बिकॉज it can get rid of that content anytime and then get it back into the main memory when it tries to read the memory again. It will come back from the file. So this is clean memory. Second quadrant में जब चले जाते हैं हम तो we have private memory and shared memory. Private memory कौन सी होगी? Private memory वो तमाम memory जो किसी एक process के लिए allocate हुई हो. एंड्रॉयड को अगर हम सिंपली देखें और हमने अभी थोड़ी देर पहले कहा कि एवरी प्रोसेस हैज़ इट्स ओन प्रोसेस स्पेस, हैज़ इट्स ओन मेमोरी एलोकेटेड, सो इट हैज़ ओन प्राइवेट मेमोरी. पुट इट दिस वे. सेकंड इज शेयर्ड मेमोरी. शेयर्ड मेमोरी इज द वन दैट कैन बी शेयर्ड अमंग मल्टीपल प्रोसेसेस. तो ये हमारे 4 मेमोरी के कोऑर्डिनेट्स हैं in which we divide our memory allocation into. अब इनकी प्रायोरिटी किस तरीके से चलती है? प्रायोरिटी इस तरीके से चलती है कि डेफिनेटली क्लीन शेयर्ड मेमोरी इज द मोस्ट प्रेफरेबल वन. किस लिए? बिकॉज फर्स्ट ऑफ ऑल कर्नल हैज jurisdiction on it, it can play with it freely, but second it is shared among different processes. So clean and shared has preference. The second one that comes in the hierarchy is private but clean. Again, because the idea is to conserve memory, and wherever the kernel has jurisdiction, that means it can free up extra memory on demand, and it can only free up extra memory on demand when it would have liberty to play with that area, and that is the clean memory. So clean private memory comes second in hierarchy, because although it is not shared among many processes, still kernel can play with it, and therefore it would have the luxury to take it in, to bring it back in, or take it out of the main memory when the requirement is. The third one is shared dirty memory, and the idea is, or the concept is same, that although it is dirty, that is the processes has jurisdiction on it, the cost is bore by number of processes. So that's why it is preferable. And last is the dirty private memory. That is, kernel cannot play with it, it doesn't have liberty to do it, and it is private, so only one process is. So these are the 4 quadrants of memory management or memory allocation. How would our program or our DEX file or our executable would fit into these quadrants? इन quadrants में हमारी executable किस तरीके से fit होगी, and then where do we gain हमारी memory efficiency इसमें कहाँ से आएगी? This is what we will discuss next time, that okay, we have defined 4 quadrants and we are trying to gain memory efficiency. So how would our DEX architecture would readily lend itself to fit inside these ones, and then from this fitting, how does our efficiency come from? This is what we will be discussing next time. Today, if I summarize the lecture, we continued discussing about the layers of Android. We started with our usual background, Linux, we talked about C, C++ libraries. Then now we are into the runtime environment. And in runtime environment, we are talking about the most crucial component, that is Dalvik virtual machine. And we are seeing that how Dalvik virtual machine is implemented to address the constraint of a mobile environment where we have limited storage, limited RAM, limited battery space, and above all, we don't have an OS space. We will continue discussing the optimization that Dalvik virtual machine has brought into Android. Till then, I'm Abdul Aziz signing off. Allah Hafiz.